liquid conductors. Let us find out whether liquids can conduct electricity or not with the help of activities. Make an electric circuit as given here. Dip the two free ends of the wire in the cap filled with vinegar. While doing so, remember that the free ends neither must be far apart nor touching each other. What do you observe? We observe that the bulb glows. How does it happen? The vinegar was present in between the free ends of the wire. As the current flows from the battery to the vinegar, it allows the current to pass through it. Hence, the circuit was completed and the bulb started glowing. Hence, we can say that the vinegar is a good conductor. Have you observed the brightness of the bulb? Is it as bright as it was in the case of the safety pin? No, it is dimmer than the safety pin. Why is it so? A bulb glows because as current flows through it, lots of heat is generated, which heats up the filament of the bulb and hence it glows. The current through the vinegar might be very weak as compared to the metals. So, a weak current cannot generate ample amount of heat and hence the bulb glows dimmer, and in some cases it does not glow at all. Our bulb tester fails to detect a weak current in the circuit. Diode or LED can be used to detect weak current. It has two ends or leads. One is longer and the other is shorter. The longer lead is attached to the positive terminal of the battery and the other with the negative terminal of the battery. We can even use a magnetic compass in our tester to detect weak current. You might wonder how it will do so. Well, do you remember that current has magnetic effect? If you keep a magnetic compass near a current-carrying wire, it will show deflection. We can use a magnetic compass simply in place of bulb in our tester. If there is any current in the circuit, however small it may be, the compass will show deflection. We can do similar tests with lemon juice, vegetable oil, milk, honey, tap water, salted water and distilled water. And we find out that the lemon juice, the tap water, the salted water conduct, whereas the honey, the milk, the vegetable oil and the distilled water do not conduct. Here we see that the distilled water cannot conduct, whereas the salted water and the tap water can conduct. The tap water contains impurities in the form of salts, whereas the distilled water is free of such impurity. So we can say that any salt added to the distilled water makes it a good conductor of current and electricity.